All right, good morning or afternoon, whenever you're watching this. So we're in week 6 for algebra, lesson 2.4, creating and solving inequalities. And luckily for you guys, this is going to be very similar to the creating and solving equations lesson that was probably around week 1 or 2. The reason why we waited all the way this time is because we had to get over a couple of things because inequalities are related, but they're not going to be the sole focus. I just need to go over how they're formed and what they are. And then we're going to move on to something else. So here, what I have here is the inequality. The definition is a statement that compares two expressions that are not strictly equal by using one of the following signs, right? And if you notice here, we have 1, 2, 3, 4, 5 different signs. Symbols are to the left, meaning is to the right. So for example, the very first symbol here, right? Uh, we have a symbol that means less than. Whenever you see it, whenever we have an equation, we don't actually have equations. We have what's called an inequality. So let's say I have this situation going on. 3x plus 1 is less than 10. What this actually means is that whatever number I end up putting for x, right, whatever number I end up solving, the number that I get has to be less than, has to be smaller than the other number. Remember, we're reading this from left to right, okay? So let's just pretend that x was 2, right? 3 times 2 plus 1 is less than 10. 3 times 2 is 6, plus 1 is less than 10. 7 is less than 10. Is this true? Yes, it makes sense. 7 is a smaller number than 10. So this inequality makes sense. However, what if it was less than or equal to the next sign that we see here? When it has the less than or equal to, let's put it underneath it. It means that it has an option. It has the option of the previous number, the number to the left, to be either less or it can be equal to it. For example, in the previous statement, if my answer was 10, 10 is less than 10, that's not true. But in this time, it says 7 is less than or equal to 10. Well, it's definitely less than. It's not equal to 10, but it's definitely less than, so it still works, right? What if instead of this, I erase this, right? And I did the other ones, right? What if I tried the third one where it says is greater than? So we had this symbol instead. Would this statement still be true? Is 7 greater than 10? No. So not true. This inequality doesn't work. What if I add the equal to, right? Is 7 greater than or equal to 10? Well, it's not greater than. It is definitely not equal to. So again, not true. So as you can see, this is a math sentence and we have to read it from left to right in order for it to make sense, okay? The last one, of course, let me just get rid of this, is similar to an equal sign, but it's not. It just means not equal to. It's the opposite of an equal sign. We generally don't use this that much, but in this case we will. So we go through all this and we read it from left to right. Is 7 not equal to 10? Do they not equal each other? This statement as an inequality is true. They do not equal each other, okay? So, this actually checks out and it's okay as an inequality, which is weird, but that's what we're gonna go over. Okay, so see if we can't move that. Example number 1, Anna is buying 12 shirts for the drama club. She will choose a style for the blank shirts and then pay for the additional charge of $2.75 for each shirt to have a club logo. If Anna cannot spend more than $99, how much can she spend on each blank shirt? Write and solve an inequality to find the possible cost of each blank shirt. Okay, so here's the thing. whenever you're dealing with these word problems, you're going to want to look for key terms. So here, it says Anna is buying 12 shirts for the drama club, right? And right here, if you notice, I have a little note for you. It says, let S represent the cost of each shirt. Um, that's supposed to be a no. She will choose a style of blank shirts and then pay an additional charge of $275. So the cost of shirts will be 12 shirts times, right, the number of shirts she's going to buy. Do we know how many shirts she's going to buy? I mean, it kind of just depends, right? We can't just write an inequality like this because when we write the inequality, you have to be very careful how we do this, right? Because it's ultimately what's important here. Oops, let's undo that. Okay. Eraser. Okay, let's try that. Sorry about that. The important thing to remember here is what's going on. She is buying 12 shirts for sure. However, whatever the cost of the original shirt is, which is S, is going for every shirt, she's going to have to pay $2.75 after it's done there. And then after that, after she pays for that initial cost, for this is just for one shirt, she's buying 12 of them, which is why we put 12 on the outside of it. Because that way we know that this will be the cost of buying 12 shirts. Now, it also says that she cannot spend more than, there's that keyword, more than, right? $99. More than suggests it's this symbol right here, right? It suggests that that whatever's to the left of that symbol has to be less than or equal to $99 because she can't spend more than $99. She can definitely spend exactly $99, but she can also spend any amount that's less than, smaller than $99, and that would satisfy this inequality, right? So that's how we came up with the equation, right? Right, and inequality and represent the equation. The next step would be to solve it. In this case, we have to use a distributive property because we have parentheses here, right? If you remember, if you think back to like week 2, the number on the outside of the parentheses multiplies by everything inside the parentheses. That means the 12 multiplies by the S. That's how we got 12S. 12 is also going to multiply by the positive 2.75. If we put that into the calculator, we end up getting 33, right? So we have 33 there is less than or equal to 99. That's what happens after we distribute. That's this step right here. We're right here. Now, once we've gotten rid of the parentheses, once we've done distribution property, we need to isolate the variable by subtracting 33. We need to get rid of that 33 because we want the S to be by itself. Now, 33 is currently positive, which is why we subtracted 33. So we can get rid of it on both sides. This cancels out, and then we have 99 minus 33. So we end up with 12S is less than or equal to 66. Now, we still need to finish isolating them. So when we finish isolating the variable, we're going to divide both sides by S. We're dividing because the 12 we've established is multiplying by the S. And we need to do the opposite to get rid of it. So we're going to have to divide both sides by 12, right? So when we divide both sides by 12, it cancels out and we're left with just regular S, or the price of one shirt before they put the logo on it, right? And then we divide that, right, by 12, and we end up getting 66 divided by 12, which is 5.5. Every shirt before she buys it, every blank shirt is worth $5.5. Then the place charges $2.75 to put a logo on it, and then she's going to buy 12 of those, and it's going to cost either $99 or less than that. Okay, so that's all the inequality means. Very similar to what we've done before. This is kind of what you're going to be doing. You're going to be making your own inequalities, and you are going to be solving pre-existing inequalities, right? So let's take a look at the vocabulary because that's really key to this. I want you to look out for the key words which are used as clues to how you need to build your inequality. For example, when you see the word more than, I've already gone over this in the previous one, it's referring to the greater than symbol, the symbol that I have here. Right now I'm currently reading right here. But if you see the word more by itself, it's probably just telling you that you need to just add whatever it is. Now, again, these rules are not going to be like the end all be all. They're not going to work 100% of the time, but they're clues. Again, if you see this, it might tell you, okay, if I saw the word more, it either means addition or it's referring to the more than symbol, the symbol that means greater than that symbol. And that's already valuable information, right? If you see the word, some of them is a little bit more obvious. If you see the word times, it's usually always going to refer to multiplication, and it's referring to your variable. Usually, like I said, usually it will be that. Whenever they say times something, times a number, times whatever, if they say a number, they're referring to, if they specifically say a number, right? They're referring to your variable, your x, your y, whatever your variable is. It can be anything, right? But they're making reference to your variable, right? And you know you're going to have a number, whatever number they told you times, in front of the x. That's how you can figure out what's in front of the x, okay? If they give you a phrase, at least, right? We're right here where it says at least, it's referring to greater than or equal to symbol, okay? So that specifically is telling you, um, it's telling you that symbol. And if you see the phrase at most, it's referring to less than or equal to symbol, right? And that gives away which symbol you're going to use, right? If they use either of those two, it's pretty obvious that they're going to be using one or the other, right? Let's look at example 2 here. Max has more than 50 carats. More than, again, it's referring to either adding or the symbol. In this case, since we only know Max and we know that he has more than 50 carats, if we make C is equal to carats, we can say C is, sorry, let's see. Did I get that wrong? Whoops. Yep, I did. I accidentally put it the other way. Okay. That's why you got to be very careful. It's supposed to be facing the other way. More than is that one, that way. So if Max has more than 50 carats, right? Carats, the value of the carats has to be bigger than 50. That's why we have this inequality saying C is greater than 50. How many carats does Max have? He has more than 50. That's all we know, right? So that's why this is the proper inequality for it. What if it's a little bit more complicated than that? What if you see something that says, okay, 12 more than 2 times a number is at least 10? Well, you end up with this inequality that you have here. Why don't we go over how I came up with that, right? Let's start with this. 12 more than. Remember how I said that the word more than is most likely referring to a symbol? In this case, we have to look at it in context of the entire sentence, right? More than 2 times the number is at least 10. There's a bunch of keywords there. More than in this case is referring to addition. That's why we have 12 more than, right? That's where we got that plus. 2 times a number. Remember, 2 times, that's multiplication. And they used it next to a number. That's why there's 2x. There's 2 times x. 2 times a number. Remember, a number means x. Is at least. There's that keyword right there. At least 10. Remember, at least referring to greater than or equal to simple. Now, we've gone over, I messed up earlier and I drew the wrong one. So let's go ahead and fix that, right? Greater than or equal to. When they say at least, right? That means that it's the minimum, right? Whatever's to the left of the equation is at minimum has to equal whatever is at the right, but it can also be bigger. It can also be anything more, right? That's what at least means. I know it's confusing, but at least is referring to something that's whatever it is the minimum and it gets bigger. At most is putting the ceiling on it. You can't go higher than it, which is why it's using the less than or equal to symbol, right? Okay. Remember key terms. All right, so one last thing. What if you're solving an inequality and you divide by a negative number? So here's another example that I have, right? We're going to walk through this step by step. This is my original equation because you are going to be given equations that are already pre-built and you need to solve for them. So this is what it would look like. But we're just going to incorporate another rule because when you, unlike equations, when you divide an inequality and you divide by a negative number, it has a very specific rule that you just kind of just have to remember. And we can go over why this rule is so important when we go over the week that we go over graphing inequalities. So here, let's go. We have 5, right here. We have 5 times, in parentheses, 6x plus 3, close parentheses, is less than or equal to 6x minus 21. All right, that is what we call our original equation. That is our problem. Excuse me. And what we have to do, well, we have x's on both sides here. But more importantly, we have the distribution right here. If you notice these arrows on top, right? That means that I needed to distribute. I'm trying to move the 5, and I'm going to multiply by the 6x. And that's where I got the 30 from, right? 5 times 6 is 30x. 5 times 3 is 15, right? Now that it looks a little bit better, I need to move all the x's on one side and all the regular numbers on the other side, all right? That's this step right here. So here, even though my goal is to try to avoid negatives, sometimes we just can't avoid them, even if we do our best. So we need to know how to deal with them when we can't avoid them. In this case, I'm going to end up with a negative either on the left side or on the right side, no matter what I do. So here, what I'm going to do is I'm going to take the 21. You see how it's a negative on this side? It's a regular number, right? I'm going to add it because I want to try to get rid of the negative. If I add it to this side, I have to add it to this side. On this side, it cancels out, but on the other side, it doesn't. So I'm left with 30x, and I just bring that down because nothing has happened to it, plus 36 because 15 plus 21 is 36, is less than or equal to the 6x just came down, and the minus 21 plus 21 cancels out to a 0. I don't have to put plus 0. I can just leave that blank, right? If I move, since I moved the regular number over, I need to move the x over to the right-hand side. The x on the left-hand side is 30, and the x on the right-hand side is 6, which means if I want to move the 30x from the left-hand side to the right-hand side, I'm going to have to subtract, which is going to lead to a negative number, which is okay. Now, here, I'm going to subtract 30, right? We're looking at this step here. And if I subtract 30 from that side, I have to subtract 30 from here. Notice the sign stays the same. Nothing's happened to the sign yet, right? We haven't reached the rule. We can subtract, add, and subtract negative numbers fine. That doesn't matter in terms of the sign, right? This cancels out. The 36 comes down. 36 is less than or equal to negative 24x. Here's when we have a problem. Now, we have a negative 24x, and we need to divide by a negative 24 for the x to finally be by itself. So when we do that, we're dividing by a negative number. And if we're dividing an inequality by a negative number, the sign has to flip to the other side, to the other sign, to its opposite sign in order to make the statement true. Okay, so when we divide by negative 24 on both sides, we end up with negative 36 over 24. And then all I did was I simplified it, from the other ones. If I divide the top and the bottom by 6, I end up with 6 over 4 negative. That's how I got that. But really what's important here is that this went from less than to greater than. It flipped. It went to the other side. Notice it still has that equal sign, and that's fine. If they didn't have the equal sign from the beginning, I wouldn't add it at the end. It would just go from greater than to less than, right? In this case, it went from less than to greater than. And I keep it the way it is here. Yeah, I could, if I wanted to, I could put negative 6 divided by 4 in the calculator, and I can get a decimal. But you can just leave things as a fraction, okay? that's all for this video. Make sure that if you guys are confused about how to do any of the problems this week, join me for my Zoom office hours. Remember, you guys get points by just checking in. Check in, ask a question, and if you check in at least once a week, you do get points for that. If you're not checking in at least once a week, you're losing easy points. All right. Zoom office hours are from 1:30 to 3 p.m. Monday through Thursday. Um, go ahead and join me. Good luck. I will post everything, and we're almost there, guys. Almost there.